Let's start chapter number 8. It is rates of chemical reactions. Overview of this chapter. Our key learning objectives are understand factors affecting reaction rates, explore collision theory, learn about catalyst and reaction mechanism, investigate practical methods for measuring reaction rates, some practical experimental design, and experimental concentration. So, key experimental factors are safety protocols, equipment selection, methodology precision, and result analysis technique. Measuring reaction rates. Here, measurement methods are product formation rate. You need to consider, see what is reactant consumption rate, observable changes like color transformation, electrical conductivity shifts, pH modification, and gas volume production. Now, let's talk about collision theory fundamental principles. So, core concepts here are reactions occur through particle collisions. Collision frequency determines reaction speed. Some factors influencing reaction rates. Factors and effect on reaction rate. Concentration increases collision frequency. Surface area, it provides more collision opportunities. Temperature enhances particle kinetic energy. And pressure increases particle interaction probability. Now, let's talk about detailed rate acceleration mechanisms. Concentration effects. More particle in solution, there will be more frequent collisions. Higher concentration, faster reaction rates there will be. Example, concentrated acid reacts more vigorously with metals. Alright, temperature dynamics. Higher temperature will increase particle movement speed, collision energy, and reaction probability. Surface area impact will be smaller particle size create more interaction points. More exposed surfaces means enhanced reaction potential. Examples, powdered iron react faster with oxygen. Now, catalyst, reaction accelerators. Catalytic converter technology, it transforms harmful exhaust gases. It uses rhodium and platinum catalyst, creates honeycomb surface with extensive interaction areas. Catalyst characteristics are it increases reaction rate, it remains chemically unchanged after reaction, it provides alternative reaction pathway, and it reduces activation energy requirements. Some key terminologies which we must learn is collision theory, which is chemical reaction mechanism explaining particle interactions. Femtosecond, 1 millionth of a billionth of a second. And catalysis, process of increasing reaction rate using a catalyst. So, conclusion here is that we need to understand reaction rate, which involves complex interactions between multiple principles, and we need to do analysis of particle behavior, energy transformation, and environmental conditions. All right, now let's talk about key factors, okay, in the rates of reaction that is affecting the reaction rate. Factors influencing reaction speed includes number 1, reactant concentration, increases number of particles per unit volume. Gas pressure impacts particle interactions. Surface area of solid, more surface means faster reaction. Temperature increases collision frequency and energy. Catalyst presence lowers activation energy. Now let's talk about collision theory fundamentals. Core principles include chemical reaction occurs when particles collide with sufficient energy, overcome activation energy barrier. Now, concentration impact, more particles means more frequent collisions. Higher collision frequency means faster reaction rate. Temperature impact, reaction rate mechanism, temperature increases, causes higher collision frequency. increases kinetic energy of particle, more collision exceeding activation energy. Catalyst characteristics key properties increases reaction rate, lowers activation energy, remains unchanged after reaction, does not get consumed itself. Some practical investigation methods include experimental approaches such as measuring reaction rates through mass changes, gas formation, and precipitation visibility. Evaluation criteria will be assess experimental accuracy by measuring apparatus precision, repeatability of experiment, and control of variables. Now, let's talk about surface area effects on reaction rate. So, key concepts here is increasing surface area will accelerate chemical reaction. Smaller particle size create more contact points for reactions. Some experimental demonstrations are marble chips experiment comparing large versus small chip sizes. Smaller chips react faster due to increased surface area. Rate measurement include mass loss can be plotted against time. Initial reaction rate is steepest at the beginning. Reaction slows as reactant are consumed. Let's talk about liquid solution concentration. What are the effects of these solutions on reaction rate? Higher concentration means increases reaction speed, demonstrated using marble chips and hydrochloric acid. Concentration impact doubling acid. Concentration can double initial reaction rate. Total reaction product remains constant. Concentration units measured in mole per decimeter cube or gram per decimeter cube. Now let's talk about gas pressure effect on reaction rate. So mechanism is increased pressure pushes gas particle closer together, more frequent and energetic collision. Example, combustion in car engines applies only to gas reactions, no effect on solid or liquid only reactions. Now, let's talk about temperature effects on reaction rate. General principle is that higher temperature will accelerate the reaction. Practical application is refrigeration slows food decay. Lower temperature reduce oxidation rates. Experimental methods sodium thiosulfate and hydrochloric acid reactions measure time for precipitate formation. Now let's talk about catalyst and reaction rates. Definition substances that increase reaction speed. Hydrogen peroxide decomposition is an example where manganese 4 oxide as a catalyst increases reaction rate without being consumed. Catalyst characteristics are increases surface area for reaction and they remain unchanged after reaction. Some comparison tables for rate of reaction factors. So surface area increases the rate of reaction and they will be having more contact points. Concentration increases more frequent collision. Temperature increase higher particle energy. Catalyst increases provides alternative reaction pathway. So, our key takeaways here is that reaction rates are influenced by multiple factors such as surface area, concentration, temperature, catalyst, and they can be manipulated. And you need to understand the factors that help control the reaction speed. With this, we have finished over this chapter. See you in our next chapter.